Specification. We'll be using 5V DC turbidity with operating current 40 mA. Response time is less than 500 milliseconds. The insulation resistance is 100 meter. The output method is with analog, and analog output is 0 to 4.5 volt. The digital output will be high-low level signal. You can adjust the threshold value by adjusting the potentiometer. The operating temperature is 5 degrees Celsius to 90 degrees Celsius. Storage temperature is 10 degrees Celsius to 90 degrees Celsius. The weight of the turbidity is 30 grams. Adapter dimension is 38 millimeter, 28 millimeter, and 10 millimeter. The pH sensor that we'll be using is the material made with PCB. The module power is 5 volt. The module size is 43 into 32 millimeter. Measuring range is 0 to 14 pH. Measuring temperature is 0 to 60 degrees Celsius. The accuracy is plus or minus 0.1 pH, 25 degrees Celsius. The response time is less than or equal 1 minute. pH sensor is with BNC connector and pH 2.0 interface. It can gain adjustment with a potentiometer. Its power indicator LED. The measurement allowed error is plus or minus 1 to 3 centimeter. The ultrasonic sensor that we will be using is high operating voltage 3 volt to 5.5 volt with software and hardware. The HC-SR04 size is fully compatible. Detection distance is 5 for the 5 volt, 2 cm to 450 cm, 3.3 volt for 3.3 volt, 2 cm to 400 cm. Detection angle is less than 15 degree. Use of industrial grade MCU. Operating temperature is 20 to 80 degrees Celsius. The connector is 4-pin header with 2.54 millimeter pitch. The dimension is 45 millimeter, 20 millimeter, and 15 millimeter. The LCD 16 to 2 module that we'll be using because 16 columns and 2 rows. The operating voltage is 4.74 to 5.3 volt. The current consumption is 1 milliampere without the backlight. The alphanumeric LCD display module, meaning can display alphabets and numbers, consists of 2 rows and each row can print 16 characters. Each character is built by a 5 to 8 pixel box, can work with both 8-bit and 4-bit mode, and it can also display any custom generated characters.
Hello, my name is Mishan Subramaniam, and today I will be talking about the challenges and the problem that we face to develop the water quality monitoring system, IoT. There are several challenges and problems that were faced during the development of the water quality monitoring system. Firstly, we had to find out the limitation of the devices quality that are in the current market. To do that, we had to look at the implementation of our device, and therefore we had to survey the market to find out devices that have the similar function and find out the lacking in those devices. Next problem that we faced is connectivity. Due to this water quality monitoring system device that will be stored in places that are hard to be reached and constantly be monitored physically, we decided to survey and develop a device that will enable to send the readings and constant update of the water quality that the system is measuring. The third challenge that we face is the physical security of the IoT devices. As IoT devices are often located in open fields. The next problem that we faced is the functionality of the device. As the water quality monitoring system IoT requires the device to work in a water-filled environment, the device that we developed needed to be waterproof and water resistant. Therefore, we had to develop the design of the system in such that the turbidity sensor and the pH sensor would be floating in the tank. By ensuring that this sensor float, the quality of the water can be monitored and the device can be prevented from being damaged by the water. The last challenges that we face is the budget for the program. Last problem that we face is keeping the project within the budget. As we had several measurements that we would like to get out of the water quality monitoring system, we had to use a cheap yet reliable sensors and setup for the device to make it scalable and suitable for the market in the industry.
Welcome to the demonstration part of this video. To begin with, I would like to explain how a simple water quality measurement with IoT is implemented. Two basic analog sensors are used. The first sensor is the turbidity sensor, which is this one. The second one is the pH sensor, which is this one. The two sensors are not fully waterproof, thus we have designed this to attach to a buoy in order to float above water. The analog readings from these sensors are handled by the Arduino Uno. The Arduino Uno is connected to a Node MCU ESP8266 module to handle IoT connection. The analyzer unit is then put inside a container, and a third sensor is used to detect if water level is sufficient for measurement. I would like to mention some design change initially at the beginning of this project. Supposedly there will be a water pump that feeds water from a source, which is then analyzed inside this container. However, the purchased water pump is damaged on receipt. So to demonstrate the water quality analyzer, a manual feed of water is required from above. The first scenario is that the unit has no water inside of it, as you can see. This is then displayed on an LCD where water level is not enough for measurement, as well as on the Blink application. Notice that there is no water inside of it. Turbidity will show an error. Second scenario is to fill the container with tap water, which is safe for everyday's use. On the LCD, it shows the pH as well as the turbidity unit, indicating that water is safe, as well as on the Blink application. The third scenario is the water is a bit contained, so we add a little bit of contaminants inside it. As you can see, the water has changed its cloudiness from clear to slightly cloudy, with contaminants inside it. The contaminated water is then analyzed by the analyzer, which is then displayed on an LCD, which shows that the NTU value is above 0, which means water is not safe for use. This data is also displayed on the Blink application. Water is being analyzed and water is not safe. Both pH and turbidity is shown in a graph. That is all for this demonstration. Thank you.
Hello, my name is Shaban Mahmood, and I'll be talking about marketing and hardware enclosure on our topic, which is about water quality monitoring system. Marketing is a very important factor, and in order to market this product into the market, the primary growth factors, today I'll be talking about the growth factors of the global water quality monitoring system. The primary growth factors of the global water quality monitoring system market include the rise in water pollution due to the industrialization, increase in prevalence of waterborne diseases, and surge in government obligations. High installation and maintenance costs are expected to restrain its global in price-sensitive markets. The lack of awareness in rural places toward health and sanitization also needs the growth of water quality monitoring system in the rural places. In order to incorporation of new technologies and new innovation techniques are going to help us to boost the popularity and demand for the water quality monitoring system during the forecast period. Some of the application and advantages of the water quality monitoring systems are the advantages are it is low maintenance cost, it prevents water diseases, it is economically affordable for common people. It is mainly helpful for water supply agency, for health department to identify the reason of water diseases. It also helps the health department. This system is also used in commercial and domestic use. So I'll be talking about the hardware encapsulation. For the hardware encapsulation, we need to mount the hardware module onto the enclosure. The benefits of hardware, the benefits of having an enclosure are it will prevent the water from splashing accidentally, and also prevent from wire short as well. And also we need to build a PCB to help our prototype. A PCB is a printed circuit unit, printed circuit board that connects the electrical components together in the board. So these are the things that we need to do in order to make our prototype better. Build a PCB, build a good enclosure for our prototype. Thank you very much.